Hi, I'm Tyler. I made my very own Beetleweight punch spinner similar to the Battlebot Tantrum, and in this video I'm going to go through why I did it, how I did it, the setbacks I encountered along the way, some of the learning points, as well as how it did in its first event, and where I plan on going from there. Before we talk about my robot, we should talk about the robot that inspired it, Tantrum.
Isn't some one-note wonder, this robot is a symphony of design. The retractable weapon used to raise eyebrows, now it cracks skulls. Oh my gosh!
Tantrum, for those that don't know, is a 250-pound Battlebot that is a spinner that sort of punches forward on a rail to hit its opponents and sort of punch it while also utilizing a spinner to deal damage. It even won a giant nut in 2022, but despite this success and despite the reputation that the team has, people don't seem to be super eager to try to replicate this design. I've only know of one guy that even tried to do it, and he shared what he did with me, but I actually haven't even seen that robot fight, and I haven't seen firsthand any fights of anybody else trying to replicate Tantrum's weapon. I'd imagine that the reason not too many people are trying to duplicate Tantrum's weapon is twofold. First off, it isn't exactly super devastating. If you watch enough of Tantrum's fights, you find that they win through control more so than having a devastating weapon that knocks their opponent out. And the second of which I will show in this video and which I learned firsthand, is that getting the spinner to move in a linear motion consistently and in a way that is efficient weight-wise is actually pretty difficult. But my goal wasn't just to make a 3-pound version of Tantrum. There were some things through the fights I watched of Tantrum that I either didn't like or I thought I could do better. First of which being the weapon. Well, not so much the weapon itself, but rather how it feeds the opponent into the weapon. They have the spinner basically go as far forward as possible out into the front in a relatively vertical front, while my front has more of a wedge, thus trying to have the opponent sort of come up on top of me, and then I have them come to my spinner instead of the other way around. The other two are the fact that Tantrum can't drive upside down and requires a separate mechanism in order to self-right. My goal was to design this robot in a way that it doesn't need a separate self-righting mechanism and is able to drive upside down. Before I get into my physical design, let's go into the electronics. With this one, I wanted to try out a Express LRS, and so I got myself a new transmitter, the RadioMaster Zorro, and the RadioMaster ER4 for the receiver. The ER4 is just pretty much the second smallest receiver that you can get for Express LRS. For the drive, I decided to go with Repeat Robotics brushless, because I wanted to have as much drive ability in the smallest package possible, because I'm going to need to be a control bot, so I need to drive fast and have torque behind my wheels, but I also can't F around with much weight, since I have to put weight into the weapon with the multiple mechanisms going on. And I decided to use the Repeat Robotics brushless drive controller because that's just the simplest way to do it. For the weapon motors, I used this servo. It's a servo off of Amazon that I know could run off of a 3S. For the spinner itself, I decided to use a motor that is more common in ants, so I used a D2822 because I'm essentially using it as a hub motor, but it's not a true hub motor. I didn't take it apart. The kV I used was 1800, but I should have definitely used a higher kV with how small my weapon blade is. For the ESC, I just used a regular B-Heli 20 amp. For the batteries, I actually have two batteries, a 4S that the drive runs on and a 3S that both the spinner and the servo run on. I'm going to go over the design by showing you guys the CAD. The top and bottom plates are both aluminum 6061, while the front, back, and side, so all the green you see here is TPU. The bottom plate has countersunk holes to hide the heads of the screws, because otherwise they drag on the ground, obviously. This does a good job of protecting the front and right tires on the side here. The wheels are big enough such that it can drive upside down and have the wheels still touch the ground, at least as long as that weapon's still there. This back needs to be round. I actually don't have a physical version where it looks like what you see here, but I did this because I was getting a poor print quality and decided to use flat surfaces so I could get a better print out of it. On the top, these are just sort of to make it lighter, though this front hole was originally meant for the switch, but the wires did not cooperate with me and I couldn't find a good way to mount it, so they're actually the switches more in the back. The two switches are kind of back here with a 3D printed part that kind of holds it in place. So if we hide the top plate, you can see that the drive motors are just sort of mounted to the back part of the robot, and they go directly into the rear wheel. If you watch the build vlogs I have, you'll know that I used a repeat robotics hub to sort of drive the rear tires, and then there's a pulley going to the front wheel. This front wheel is mounted using a shoulder bolt that is literally super glued into this part. It's not a thing I would recommend you doing, and I definitely will find a better solution in the future, but it's what I went with. This feature here originally wasn't there, but I added it after some of the electronics would shift and push into the tire and kind of create a bunch of friction and cause the robot to not drive straight. For the batteries, I'm doing it this way so I can remember which is left and right. On the left side, there is the battery and electronics for the weapon, and then the drive battery and speed control is on the right. I end up kind of having issues because of the timing belt has to go through right here, and keeping all the electronics there was a pain in the neck. Some future iterations I'll have a better way of having wire management kind of built into the design. I'll go into the weapon specifically in a moment because I have some specific views, but essentially this part slides along some shafts. I tried some steel shafts, but I also tried some tungsten carbide shafts that are a bit stiffer. So I'll go into how those worked out once I talk about the event itself. If you enjoy this part of the video, then you'll probably enjoy my live streams, which I do 7 p.m. Thursday. I usually just work on CAD and give you guys a chance to ask questions in chat, although I do have some special ones planned, such as before the Thursday before MRCA finals. I'm going to do one where I look at the bracket and kind of work on a game plan live with you guys and kind of just get us hyped for finals. So be sure to subscribe if you want to catch that. And without further ado, let's get back to the video. Let's talk about the weapon assembly. These holes are slotted. They're to mount the motor. I ended up slotting them because I was having a pain in the butt. It was a pain in the butt to try to get them to line up, and so I made them slotted. It just made my life easier. These holes are for a pin, so I can use it as a weapon lock. This little feature is meant to sort of, for the wires to sort of come around and try to keep it out of the weapon so they don't, so it doesn't murder itself and snip my own wires. The spinner part itself, we have a TPU hub and an AR500 ring. The screws sort of keep it. These screws are longer because I expected a wider ring originally, but I changed it later and used shorter screws. This ring is 2 inches in diameter, which is tiny. I'll go more into what I want to do with that later, but in this iteration it's 2 inches in diameter. This is just a hole for a bearing, and this feature is for holding a timing belt, so I can make it go back and forth. This part is actually, it's one piece here, and originally I made it as one piece, but then I realized that I was dumb and that there's actually no way to put the motor in there when it's one piece, so I ended up making it two pieces in the configuration. So essentially I went to the configuration and added a cut for the left side and then a cut for the right side. And there's the screw holes that screw it together, and the problem with this was that since they're 3D printed polycarbonate, this side is printed with that face down and created layer lines, and even though it was made out of polycarbonate, it broke along the layer lines. So I'm definitely going to do something different, and I'll go into that later. So let's talk about the punching mechanism itself. The servo is mounted into the back of the robot, into the TPU using plastite screws. The red line is the timing belt with this perpendicular line to indicate an end point. This front pulley is inside of the front wedge, and I literally have to bend it because it's TPU in order to get it in there. Then we have a tensioning device and a pulley here, like it's just a go build a pulley. The problem I had with this one is that it would slip sometimes on this pulley here, so I ended up trying something else. I'll go into that to a second, but I also had an issue where it's not, you can't see it here, but the wires would come out the side, and that would kind of hit this part where the servo is, so I may need to change that in the future. There's another solution that I tried where I replaced the Go Build a pulley with a 3D printed part that essentially fixed one end of the timing belt, and I pretty much only used the servo to pull back, and then I had a spring pushing it forward. A problem I ran into was that the servo would be able to sometimes be able to pull it back, but not every single time. I'm not sure if there was some friction or something going on, but ultimately it didn't really work, but it worked enough that I did use it at some of the fights at the event. While I was at the event, I had an epiphany on how I should have done it and how I'm going to do it in the future. Basically, I need to fix the ends at both the weapon slide and at the pulley. This should eliminate any slippage, and I'm already halfway there because I already designed the part to hold the fixed end at the pulley. I just need to have it going in both directions. I should mention that I have two configurations for it, one with a titanium wedge and another with AR500 forks. For those of you that follow my build vlogs, you'll know how much of a nightmare that building this thing was and how many problems and janky stuff I had to do to get this thing working. The build plate, I was dumb and didn't make it symmetrical, so I accidentally ended up tapering the holes on the wrong side. So when I got it from Send Cut Send, I had to get it redone. Luckily, Send Cut Send's super nice, and they redid it without me having to like pay again. Then there's the whole electronics basically being taped into place and them shifting into the tires. Luckily, I was able to fix that by the time we got to the event. Then there's the whole thing with the wheels and them spinning because I didn't use any sort of hub because the Overture Easy Nylon is entirely too soft, and I'm going to get away from that filament. I found that there's basically no reason for me to use it over like PLA Plus or polycarbonate. Then there's the whole fact that the weapon assembly, like the punching mechanism, I tried it two different ways and neither worked. Because the one would slip and the other one would end up just not being able to pull it back. There's so many parts I just kept having to redesign because I made some stupid mistake. Hell, the front wheels are on a shoulder bolt that's literally super glued to the side of the robot. This thing is a hot mess. There are a couple things that did work out well for the robot. It does drive upside down because the geometry of the weapon it makes it so the back wheels can touch the ground without the spinner hitting the ground. Also, it can self-right, not the way I intended. I originally intended using like the punching mechanism backwards in order to self-right, but instead it's so bottom heavy because that aluminum bottom plate, and it's so fast that by just driving forward it self-rights. So that works, I guess. And then there's the whole fact that the switches didn't end up being where I wanted them to be. The whole thing is difficult to assemble because it's like the first iteration, so I didn't quite have it optimized to be able to be assembled or to have maintenance done on it. I had to tape the electronics to the top of the robot in order to get everything to fit into place without colliding into other things. The back of the robot looks pretty bad because of the print quality that's on there. So going into the first event, I was not feeling super stellar, like every part about building this thing. And also there's the whole fact that this was supposed to go to an event a month before RSL. There's IFRC I was trying to go to, which was a month before RSL. And I was still working on this like the week before RSL. So that's how that went. So I was not feeling confident about this robot going to RSL. I was basically at that point essentially being like, I just need to get this to an event. I need to I've built all these parts. I want to get some like data on how it works and it was like sunk cost fallacy at this point. I did manage to get Hodag event ready eventually. It went to RSL at Hastings towards the end of the MRCA season. So there was theoretically a possible situation where it qualified, but I wasn't really counting on that, to be honest. Since it's modified Swiss, I was hoping to get one win because I figured I would lose enough that I would eventually reach the point where I could beat a robot. So let's get into that event and see how that went. Our first fight is against a two-wheeled vert called Stress Concentration. You can tell that I'm having troubles controlling the robot because it just turns so quickly and having troubles facing. You'll also see me occasionally run into the walls. I'll definitely have to change something on the controller and be able to control it better. I am able to push. We end up fork locking a lot in this fight, but most of the time I'm able to push him back. That's really the brushless motors doing what they do best. I'm also pretty sure that I forget to have the spinner on during most of this fight. Because I don't think I was even spinning when I hit him in the back like that. I really need to get used to controlling the drive, but also controlling the weapon mechanism. It's a little much more complicated than Bigfoot, and I'm not used to having a spinner. But that comes with practice. He gets a pop underneath us there. Yeah, he's kind of getting that underneath us here, so he gets a pin. A lot of back and forth. Is pretty close for most of this match. I'm just trying to do my best to try to control, since that's what this bot is built to do. Get a nice pin here, able to get him up on the kick plate. But he's able to get down pretty easily. Right here. Oh, not right there. Here's where he gets one last pop, and we're upside down to end the match, which is not how you want to see for the judges. But once our wheels touch the ground, we are able to self-right pretty easily. He ends up getting the judge's decision. Probably has a lot to do with actually being able to hit us with his weapon, because we weren't able to control the fight that much more than he did. So at this point, even though we lost, Hodag did a little bit better than I was expecting. We didn't take any damage, so that's promising, because like I mentioned before, this thing is a pain in the butt to assemble and disassemble. So not taking damage is amazing for us. So at this point in time, I'm just glad we don't have to fix anything, and I know I just need to dial in and get used to driving. So our second fight is against a D2 wedge called the Trooper. They've been to RSL a lot and have been pretty successful. We mess up the box rush, I guess, even though we don't really need to box rush them. I end up just going, having the weapon forward the entire time and spinning the whole time. We're able to get underneath him pretty consistently, and we're faster than him and have more drive power, even though he has 4 brush motors. Our 2 brushless are able to push him. Yeah, having forks against their wedge just really works out for us. They also went into this fight with a compromised drive side, so that is sort of an advantage for us this whole time. I don't know why they did that, because in later fights we actually see them replace that motor. I'm not really sure what their thought process was. Maybe they were overconfident. But even when we get upside down, we're able to immediately self-right, which is pretty good. Overall, you can see I'm getting a little bit more used to driving it. I think pretty soon is when I decide to turn... Oh, Okay, I think after this is when I decide to turn the weapon off, because I want to conserve my weapon. I don't know how long the battery's going to last, and I just don't want to go down and lose the judge's decision, because I'm feeling pretty confident that we're going to win. But yeah, we get one last pin in, and as unsurprisingly, we get the judge's decision there. So far, Hodag is surprising me. Unfortunately, our opponent for the third round fight had to forfeit. So although it counts as a win for the tournament, it does not count for anything as far as ELO goes. And since I wasn't really confident about our abilities to make the bracket, it's just one less fight, and that would be super disappointing to only get 3 fights in that day. Our fourth round fight is against a 2-wheeled undercard called Grimm. Obviously, we go with our wedge configuration. The winner of this fight moves on to the single elimination bracket. We get him upside down pretty quickly. We're able to get a pin in pretty quickly, so that's pretty good. I'm really sketched out by him being upside down. I should have gotten a punch in there, but I was dumb and didn't. They're just both moving around a lot. There, I'm able to push them into the wall a little bit. Our weapon ends up going down at some point, so I'm keeping an eye out for that. During the moment, I wasn't sure when it happened, because there's a lot of near misses where he could have taken it out. It might have been right there where he takes it out, hard to say. But even if he takes out our weapon, we're still able to control the fight, pushing him around. He isn't able to damage our drive pretty much at all. Still trying to be aggressive, whether we have a weapon or not. We pretty much dictate the pace of this entire fight. It ends up going to a judge's decision, which we end up winning, even though he ended up obviously getting damage on us because he took out our weapon. We were a little bit more aggressive, and we had much more control throughout the whole match. So we end up winning this one and moving on to this single elimination bracket. With all the BS I had to go through in order to get Hodag working, and how unconfident I was in Hodag's performance, I did not expect Hodag to be able to go to the single elimination bracket, even though it did happen partially because of one bot forfeited. The next fight was against a 2-wheeled beater bar called Skippy. So Hodag's definitely getting a wide range of bots today. I'm trying to go along the side, I think. Pretty much immediately get underneath him, and he immediately devastates our weapon because of that drum, and just does more damage to the weapon. And our fork gets pushed upward and is stuck there. And now we're upside down with that fork, and we're struggling to move. And now the fork is inside of his beater bar, and we end up having to get unstuck here. Oh, and also that weapon is now completely disassembled. I actually ended up checking out the motor later. The motor is more or less fine. It's just the wires are completely destroyed. So if I was motivated enough, I could probably salvage that motor. Also, Casey is nice enough here to unscrew up my fork like it's going to matter at this point. And he gets one hit on us, and we end up in a position where we can't get off of it. Without that weapon assembly, the slide assembly there, we can't keep driving because our wheels aren't at an angle to touch the ground, so we end up getting counted out and we end up losing that one. All things considered, I think going 2-2 at that event wasn't too bad. The main body of the robot is nigh indestructible, but there are a lot of things I need to work on. First of which being just driving it and maybe even mixing on the controller to make it so it doesn't turn so aggressively, because definitely you could tell I needed some getting used to the speed on that robot. I forgot to mention this earlier in the video, but for the forked configuration, I actually had tungsten carbide shafts, while with the wedge configuration, I had steel shafts. And in the Grimm fight, the shafts got super bent up, and I may try to salvage them, but we'll see. But the tungsten carbide shafts were perfectly straight, and I'm kind of worried that they might shatter, but they ended up staying pretty stiff, so I might continue with that in the future. At the event, I actually made a list of things that I wanted to change. I wanted to change the bottom plate so that it's made out of polycarbonate instead of the aluminum. The aluminum is a crazy amount of weight. We'll see how that affects the self-writing, but I think being able to 3D print it out of like polycarbonate or PLA Plus will allow me to keep the electronics out of things as well, and also free up some more weight for other stuff, and also possibly mount the servo to something more rigid than that TPU, because you can kind of tell in some of the videos of my weapon tests that the servo sort of ends up moving as it moves the weapon assembly. I need to make changes to that weapon assembly itself, because like I mentioned before, the layer lines were a problem, and before I even got into really any fights, that thing was held together by tape. Instead, I was going to print both sides basically flat to the build plate and then have spacers going between them. I also at some point want to switch to a hub motor, an actual hub motor, not just because it'll be more survivable, but that way it can be mounted on both sides, so that can help hold together that assembly. I also want to change the tires up, or specifically I want to change the front tires so that they are outward instead of inward, just to give a little bit more room for the electronics. I'll have to obviously change the sides of the robot in order to accommodate that, as well as the bottom, which should be fine because I'll end up 3D printing it. I also need a plow for the front, or to keep the other robots from going all the way on top of me, because I want to be able to have part of my robot underneath them, but I don't want them to be able to go all the way to my weapon when I'm not trying to punch them. So I'm thinking about doing that possibly out of UHMW. Also, if I can swing it, I want to have an extra 1/2 inch to that weapon diameter, because that 2-inch weapon diameter is minuscule. I also obviously need to do something about the forks so they don't do what they did in the Skippy fight to limit rotation. I thought what I did was enough to limit rotation, but clearly it wasn't. Even though Hodag unsurprisingly didn't qualify for finals, I might make some of the changes to Hodag and then bring that slightly changed version to finals for grudge matches, or a grudge match at least. That way I can use some of the old parts before I do a complete redesign. But I think with that update, I'll just do the changes to the punch assembly, because all I need to do is redesign that one part and cut some different timing belts. I'll redesign the weapon assembly itself, maybe not with the larger diameter, or with the hub motor, but with the different mounting and the spacers and whatnot. And I also will try out the UHMW plow. It won't be like a fancy CNC'd machined one. It'll be a little bit more quick and rough version of that, just to try it out. My plan is to get Hodag to NHRL at some point in 2025, but I want to get 2 more Midwest events in there before then. So if you want to catch that and follow Hodag's journey, be sure to subscribe so you can catch those videos. And if you're looking for something else to watch, on screen should be a video of how I built my Antweight Bigfoot.